Today's lesson is on finding the volume of three-dimensional figures. So we start out with some formulas over here for volume. Notice the prism says volume equals capital B times H. Cylinder is pi r squared H. Pyramid is 1/3, capital B H. Cones and spheres, I'll let you just see those. Those are also on your formula sheet that we have linked on the Canvas page. The capital B, this is important. Capital B stands for the area of the base. So in different times here, we're going to pick a particular part to be the base, and that's what we're going to, capital B means we found the area of that piece. H represents the height. Remember, the height is always perpendicular to the base. And R, of course, the radius of a circle. The only thing you have to be careful of on, let's say, cylinders and cones and spheres is when they give you the diameter that you go back and find the radius. So we're going to start with a rectangular prism. So this one has a formula of capital B times H. You probably remember this formula as like LWH, length times width times height. That's a rectangular prism, just a simple shape here. Now these numbers are hard to see. This is 3, this is 9 inches, and this is 5 inches. Now, the first thing you want to do when you're dealing with a prism of any kind is to choose which part's going to be your base. So what I did on this one is I decided to make this my base. You could make any part of it your base in a rectangular prism. In other prisms, you're pretty much restricted. But on this one, I'm going to pick that to be my base. So the area of my base is going to be 9 times 5, because that was a rectangle, 45, and the height of my prism is 3. So all I need to do is 145 times 3, I'm sorry, 45 times 3, and get 135. That's where my brain was going. And it's volume, so I'm in cubic inches. So a rectangular prism is probably the easiest. It really is length times width times height. So when you see this formula, capital B, H, the base is a rectangle, so that's the length times the width. So that one's pretty simple. Now it gets a little bit different. This is a triangular prism. So when they start naming prisms different shapes, that shape is the base. Your bases are your two sides, the congruent sides that are opposite from each other. And I think I have a bigger one that's easier to see. There we go. So on this one, this triangle is my base. So I'm just going to draw this over here so we can see it better. Here's my triangle. This is 4 right here. And if you look down here, this side's 3. So if my base on this one is a triangle, the area of my base follows the triangle formula. 1/2 little b, base times height. So on this one, the base and the height are 4 and 3. So the area of this triangle is actually 6. That's my capital B for this formula. So now I use the formula volume equals area of the base times the height. Now this height was referring to the height of a triangle. This height in the volume formula is the height of the prism. The height is the distance between the bases. That kind of helps you think about things. So how far is it from the base to the other base? That's our height, which on this one, if you cannot see, is 10 inches. So the volume of my triangle, which is the base, those two parallel shapes are the bases, 6, and my height was 10. So this one is 60 cubic inches for my volume. All right, next up, I have a cylinder. A cylindrical fish tank provides 360 view. Calculate the amount of water the tank will hold if. and they give us all this information. So I'm going to write down the formula for a cylinder. Truthfully, it's still B times H, but when you think about a cylinder, what shape is the base? It's a circle. So the formula you see on your chart probably says pi r squared h. Pi r squared is the base, that's the circle, and then the height, the distance between the two circles. So they tell you the height of the tank is 30. I can put 30 in for h. The length of the diameter is 27.5. So remember, the diameter is all the way across, but my formula calls for the radius. So all I need to do is 27.5 divided by 2. I get 13.75 for my radius. 13.75 squared. So pi times the radius squared times the height. So I go back and grab my calculator, and I'm going to multiply my radius squared times my height. So I get this number, 5671.875 pi. And I believe that's cubic inches. Now, sometimes we're going to ask you to leave your answer in terms of pi. So that means multiply all the other numbers, but don't actually multiply the pi, because that's kind of a nicer looking number. Now, in this particular problem, they want you to find the amount of water the tank will hold. Well, if this is my volume in cubic inches, and then they told me that 1 gallon is 231 cubic inches, to answer this question, I do need a decimal here so that I can divide it by 231. So I'm going to go ahead and take my answer and multiply it by pi. And you see the pi is the blue button here right underneath clear. So second and that little caret. Answer times pi gives me this 17,818.72083. And all I need to do to find out how much water, that's how many cubic inches, I want to know how many gallons. I'm going to divide it by 231 to get my approximate answer. So I said calculate the amount of water the tank will hold. I got 77 points, all of that. So I'm going to say approximately 77 gallons of water. That's a big fish tank. All right, let's move on to the next one. This is an interesting concept here. We're going to revolve a 2D shape around an axis. So, I'll show you how this works. I plot these 3 points, 0, 0, 3, 0, and 0, 6. 1, 2, 3, 4, 5, 6. Notice when I connect the dots, that makes a triangle. Now we're going to take this triangle and we're going to revolve it around the y-axis. So what I do to picture that is first I just kind of reflect it over the y-axis. And then imagine if you just, like a revolving door, I know the library has some revolving doors that go around and around. If I take this triangle and revolve it, what shape do you think it's going to make? You see what happens when I revolve? What shape is it? It's a cone. The radius of the base is right here, it's 3. The height is 6. Now be careful, sometimes you revolve around the y-axis, and sometimes we would revolve it around the x-axis. So if we revolved it around the x-axis, it would look like this. And the radius and the height would be different. So be careful, be very careful which axis you're revolving around. But on this one we identified the radius was 3, the height was 6. So now we can find the volume. Well, the volume of a cone was 1/3 pi r squared h. It's odd that a cone is 1/3 of a cylinder. Just interesting to note. So now I plug my numbers in. 1/3 pi, radius was 3, height was 6. Now I'm going to leave this answer in terms of pi because it's a nice exact answer. So on this one I'm going to do 3 squared times 6 divided by 3, because 1/3 is the same as dividing by 3. Or if you wanted to, you could always go to your fraction and put the 1/3 in this way. 1/3 times 3 squared times 6. So you get 18. So this answer is 18 pi. And there's no units on there because we were on the coordinate plane. So if you wanted to be particular, you could put units cubed. Most of the time, we will ask you to leave your answers in terms of pi. So just know that. And anytime you have to enter that on an online quiz, we're just using pi. That's the Greek letter for pi. Alrighty. Here's another rectangular prism. I think we've got a good handle on that one. Remember, it was capital B times H. I think we already did this one. Let's take a look at this triangular prism. This one's a little bit different. Notice there's a triangle here, and there's another triangle here. So when we talk about our capital B, it's a triangle, because whatever kind of prism it is, those two parallel bases, those are our bases. So we take a look at our triangle. That's a 4 centimeters for the height, and I believe this is an 8 centimeters for the base, and there's a 20 over here. So for my triangle, I'm going to do 1/2 of 4 times 8, which gives me 16 for capital B. So when I go to my volume of a prism formula, when it says capital B times H, my base was 16. The distance between those two bases was 20. That was my height. So 16 times 20 is 320 cubic centimeters. So just always note what shape your bases were when you do the capital B for these. All right. Here's another revolve a shape question. So we'll take a look at that. This one has us plotting 4 points, 0, 0, 3, 0, 3, 6, 6, and 0, 6. So this time we have a rectangle. So this one really is like the revolving doors at the library because it's a rectangle. We're going to revolve it around the y-axis, so we know that it's going this way. So the first thing I'm going to do is I'm just going to kind of draw a reflection over the y-axis. And then if I'm going to revolve around the y-axis, my circle goes this way. And this one's going to go this way. So when I revolve a rectangle, notice the shape it takes on. When you revolve a rectangle, I get a cylinder. So remember, when we revolved a triangle, we got a cone. When we revolve a rectangle, we get a cylinder. The radius, right here, the radius of the base is 3. The height of the cylinder is 6. And we're ready to plug numbers into our formula. Now remember, if we rotated around the x-axis, those switch places. The radius would then be the 6 and the height would be the 3. So just be really careful about your axis. Volume of a cylinder, pi r squared h. Pi r squared represents the circle on the bottom times the height. So we plug our values in. Pi times 3 squared times 6. And I believe our answer is 54 pi. If the question asks you to round it to the nearest thousandth, this is, by the way, this is the exact answer, or if we ask you to write it in terms of pi, that's the answer we're looking for. If we're rounding it to the nearest thousandth, you grab your calculator and you type in 54 pi. On your calculator, you don't have to tell it times pi because it automatically knows that means 54 times pi. And that gives you 169.646, rounded to the nearest thousandth. So we can do it both ways depending on the directions. Let's talk now about a square pyramid. I know this pyramid might be hard to see. I will tell you that this is 7 meters and this down here is 5 meters. When they tell us it's a square pyramid, that means the base of our pyramid is a square. The base of your pyramid could be a triangle, it could be a rectangle, it could be an octagon, but most of the time it's going to be a square pyramid. So my formula for volume says 1/3 capital B H. Capital B represents the area of the base. So on this one, here's my base. It's a square because they told me. So all the sides measure 5 around the base. So what's the area of my base? Well, it's a square, 5 times 5. And the height from the tippy top perpendicular to the base, there was a little right angle there, the height was 7. And we plug that into our calculator. So 25 times 7 divided by 3. Oh. If they ask you to round it to the nearest thousandth, you could say 58.333, or I personally prefer it as an improper fraction because it's probably easier if you did 1/3, you have to put 1/3. 1/3 times 25 times 7, you would get 175/3. So these two are equivalent. This is just the exact answer, and this one is rounded to the nearest thousandth. So it just, again, depends on what the directions ask you to do. Alrighty. Next up, they're asking us about the Rainforest Pyramid in Galveston, Texas. It's a building that's 100 feet high, has a square base with sides that are 200 feet. So this is basically the same question we just finished. We've got a pyramid, a square pyramid. The base edges are 200 and the height was 100. So we would solve this exactly the same way we did the other. 1/3 capital B times H. And since our base is a square, 200 squared is 40,000 times 100. And we end up with a really, really big number. I believe it is, let's see, 1, 2, 3, 4, 5, 6, 1, 2. Let's see. 40,000 times 100. How many zeros do we have there? 1, 2, 3, 4, 5, 6. That's 4 million. Over 3. If you were going to leave that in the exact form. And of course we could divide that and get a decimal equivalent if we were asked to. So that's all we'll say about that one. Next up, we're going to go to this one. We're going to revolve a 2D shape again. But notice what we have this time. We have points -4, 0, 0, 4, 4, 0, and 0, -4. And we're going to connect these, and I'm going to do my best. I failed already. And try to make a circle. Okay, you have to pretend like it's a lovely circle. So what do you think is going to happen when we rotate our circle around the y-axis? Now on this one it wouldn't matter if I was doing the y-axis or the x-axis, because guess what happens? I get a sphere. You just get a ball. And all we need to know about a sphere in order to do our calculation is the radius, because the volume of a sphere is 4/3 pi r cubed. So we take our radius on this one, which is 4/3 pi times 4 cubed. And we put that in our calculator. So I'm going to do alpha y equals gets me my fraction. 4/3, I'm going to skip pi for right now, times 4 to the 3rd power, and I get 256/3 times pi. Now you could also write the pi on the top with the 256. If it's over on the side or if it's on the top, it means the same thing. So I like this answer because it's clean, it's exact. But if you were to round this to the nearest thousandth, take your 256/3 times pi, and you would write approximately 268.083. So just, I want you to be able to do it exactly or rounded to the nearest thousandth. Okay. The next problem we're going to look at is finding the volume of a hemisphere. So a hemisphere is just the name we use for half a sphere. You know, semicircle or semicircle, whichever way you say it, is half a circle. Well, hemisphere is just half a sphere. So we do the sphere formula and take half of it. So on this particular problem, if you're not able to see it, the radius is 9. So all we have to do in our formula is do our 4/3 pi times 9 cubed, and then take half of that. So all I'm going to do is put all these numbers into the calculator except for the pi, and that'll give me the answer in terms of pi. So here's my, if you like the fraction button, that's a good one to use here. 1/2 times 4/3 times 9 to the 3rd power. And that gives me 486 pi. Just don't forget when you're in terms of pi to put that pi at the end. And I believe we were in, I wrote over it, I'm going to say meters because I can't read it. So there's our answer, exact in terms of pi. And most of the time you can stop right there because that's my favorite way for you to give the answer. So putting it in decimal form, just that's an extra step, that's more work. And most of the time you don't have to do it. All right, I think there's one more picture for us to look at. We call this one a composite figure because we put two shapes together. So we're going to have some ice cream. Sounds yummy. And let's say we have a cone filled with ice cream, and then we have this shape on top with our scoop of ice cream. So the question is, how much ice cream's in there? So we're going to find the volume of the cone plus the hemisphere, because you recognize that that was half of a sphere. So we're going to add these, we're going to find the volume of each and add them together. So what I like to do is to kind of set everything up. I'm going to talk myself through it. I'm going to say, I'm going to find the volume of the cone plus the volume of the hemisphere. That's my process. Now I'm going to write my formulas. Volume of a cone is 1/3 pi r squared h. And the volume of a hemisphere we just did was 1/2 times 4/3 pi r cubed. Now for us, the radius for the hemisphere and the cone is the same, r equals 4. And then for the cone, we have a height of 10 centimeters, because remember the height is from the tip perpendicular to the base. So all I do is plug these numbers into my formulas, and I should be able to get a good answer. So here's 1/3 times pi 4 squared times 10 plus 1/2 times 4/3 pi and then 4 to the 3rd power. So I've written all my numbers out. I just plug them into my calculator. So let's see what happens. Get it where we can see it all. All right, I'm going to do 1/3 times 4 squared times 10. That's going to give me 160 over 3 times pi, plus the second one, the hemisphere, 1/2 times 4/3. Well, that didn't go right. 1/2 times 4/3 and then 4 to the 3rd power. I think I forgot to put my times there. I think the calculator knows what to do. That's 128 over 3 times pi. And let's see what happens when I add 160 over 3 plus 128 over 3. Now, some of you don't know this little trick that if I highlight something and hit enter, that's just a copy and paste that this calculator will do. Let me go back. I need to add the 160 over 3. Add those together, I get 96 pi for how much ice cream is in my cone and the little hemisphere on top. And again, if we asked you for simplest or for rounded to the nearest thousandth, you would simply multiply 96 times pi. And you'd get approximately 301.593 cubic centimeters. Honestly, this is my favorite. We're gonna ask you for this more than anything else. So there's your volume of some different shapes.